Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 286. Please turn to page 286, and today is our lesson number 166. Problem number 123 is what we're going to solve on page number 286. Let's take a look at it. It says the range of numbers in set S. The range of numbers in set S, we are told, is X. The range of numbers in set T, we are told, is Y. We are also told that all numbers in set T are also in set S. All the numbers that are in set T are also in set S. Which tells us that set T must be a subset of S. All the numbers in set T are also in set S. The question simply is X more than Y? In other words, they're asking us, is the range of numbers in the superset, the set S, greater than the range of numbers in the subset, the set T? That's all it is. Let's see what they tell us. They must tell us something juicy. The set S consists of 7 numbers. All right. Set S has 7 numbers, and that's all they tell us. That is all they tell us. They tell us nothing at all about set T. But we can infer from that. We surmise from it, what we gather from it is that set T must have 7 or fewer members. Is it possible for set T to have 7 members? Of course it is. Why not? If set T has 7 numbers or 7 members, whatever you want to call it, the units in the sets are called members. They are referred to sometimes as members. Some mathematicians refer to them as elements. So set T has 7 elements, 7 members, or in this case 7 numbers, or 7 people, or 7 cars, or 7 cows. It doesn't really matter. 7 something. It could have as many as 7. It will still be true. If set T had 7 members, it would still be true. It will still be correct to say that all the members in set T also belong to set S. It's just that in that case they will have the same number of elements, same number of members, same number of thingy-mabobbers. Do you understand? So what does it tell us? So there is one possibility here, set S. It is quite possible that set S may be something as simple as, to keep the 1, 2, 3 all the way up to 7. Now if that were the case, the range in this case, the range of set X, range of set S, which is X in this case, would simply be 7 minus 1, or 6. And it is also possible that our set T could just have 2 elements in it, just have two members in it. But the members are like this, 1 and 7. In which case, the range of set T is also 7 minus 1 or 6. They are both equal. So the question was, is X more than Y? In this case, X equals Y, and therefore the answer is no. Or, it is quite possible that set T may have, instead of 1 and 7, set T may have 1 and 6. In which case, Y would be 6 minus 1 or 5. And here, X would be greater than Y. So we cannot tell. Just simply knowing that one has 7 elements and the other one has fewer than 7, equal to or fewer than 7 elements, does not tell us at all about their respective range. Because we don't know how many members there are in each, and we don't know what the exact entries are. And until we know the exact entries, there is no way for us to ascertain their range. So first statement by itself is not enough. First statement by itself is not enough. Since the first statement by itself we just found out is not enough, we know now that A, D, B, C, D. Since the first statement by itself is not enough, we know now that answer cannot be A or D. To say nothing of the fact that we have not even contemplated the weird scenario, the peculiar scenario, the kinky scenario, the kinky possibilities. For example, or for all we know, set S, our so-called set S, could have 7 elements which are like this. 1, 1, 1, 1, 1, 1, 1, 3, 6, voila. In which case, the range is 0, a big fat 0. And we could have set T consisting of only 2 or 3 elements. Here the range again would be 0. Or if it turns out that set S consists of 1, 1, 1, 1, 1 and at the end it happens to be 100, in that case the range would be 99 and this will still be 0, and therefore we cannot tell if X is greater than Y or if they are equal to each other. It can go either way. Let's look at second statement. In the second statement they tell us that set T consists of 6 elements. Set T has 6 elements. As I said, they are referred to as elements, they are referred to as members. Here, because these elements, these members happen to be numbers, they just call them numbers. But like I said, they could be anything. So set T has 6 elements. What does that tell us? For example, our so-called set T could very well be 1, 2, 3, 4, 5 and 6. It could have 6 trees, in which case the range would be 0. The range would be 0. And our set S could also have exactly 6 elements, or 7 elements if you like, or 70 elements or if you like, but they are all the same, therefore their range is also 0. So here X does equal Y. But what if set S has 7 elements, but the very last one, instead of being 3, happens to be 30? If it happens to be 30, then the range here would be 30 minus 3 would be 27, and now X is not equal to Y. The question here is this X greater than Y? Well, in this case it is. X, I have it the other way around. It should be X and Y. X on the bottom, Y on the top. So in one case X is greater than Y, in the other case they were two equal. It doesn't have any, it doesn't provide us much information to figure out their respective range. Second statement by itself is also no good. Answer cannot be B. Let's put them together. If we put them together, we will have the same scenarios as before. We'll have the exact same scenarios as before. The only difference is that now we know that one set has exactly 6 members, the other one has 7 members, but it doesn't alter the fact that because we do not know their respective entries, we cannot ascertain their precise ranges rather, their precise ranges, not range. And therefore we cannot tell if the range of one set is equal to or greater than the other. It's impossible. The answer is E. The answer is E. I'll see you tomorrow, okay? Bye now.